Hi, in this video we will learn what is a solid of revolution and how we can find volume of such solid. Assume that we have a positive continuous function on the interval a to b. Then if you consider the graph of this function, we can make the region under the graph of such function, yes, a to b. So this is the region under the graph of that function. Then we can do an operation which will generate a three-dimensional object, and that is rotate the region about x-axis. So if you do that thing, so let me just generate this. Okay, what will happen is this, that we will start getting a three-dimensional object which has very nice symmetry like that, and yes, what generate a three-dimensional object like this one, yes. Such an object is called solid of revolution. So it is a solid, a three-dimensional object, which we get by rotating a region about x-axis or y-axis. This is called solid of revolution. How to find volume of such a solid? Volume of solid of revolution. Well, the trick that we use for the area, we can use it here again, but this time instead of having rectangles, we can make small discs out of this object. So in other words, you chop it into thin discs around every given point x, while the thickness of the disk we are going to take to be delta x, and the radius of such a disk, you see, if I just draw it here, it's going to be f of that sample point from the ith interval. Okay, and well, if you're looking for the volume of approximating disk, well, that is a cylinder, yes. The base has pi radius squared times the height, which is delta x. So this is the volume of one disk. But then you add all such disks squared, and well, make sure that you increase the number of such disks, so make them thinner and thinner. So this way we will get the volume of the solid. So this is a sum, limit, and sum formula. But if you look at this thing carefully, this will give you a Riemann sum of the integrand pi fx squared dx. Well, that is the formula we are going to use. So the volume of solid of revolution obtained by rotating the region under the graph of positive function f on the interval AB about x-axis is given by integral a to b pi fx squared dx. Well, the best way to remember this thing is the area of the base or area of a circle radius f of x. Pi r squared. Remember this thing. Pi, this is r squared, and then delta x is the height of the cylinder. Well, let's see this in some examples. Okay, find the volume of solids obtained by rotating the given region about x-axis. Okay, what is the region? We have to first figure that out. So we have the linear function y equal to x, and x-axis, this one, and let's say this is x equal to 1. You see that the region is this guy. So if we start rotating this about x-axis, what we will get is, well, let me just draw it again. What we will get is going to be a cone. And since this is solid of revolution, we know what to how to find volume of the solid. It will go from 0 to 1 pi. F of x here is just x itself squared times dx. Pi x squared dx. So this will x squared dx. Now find antiderivative of x squared, which is x cubed over 3. Go from 0 to 1. This will give us 1 cubed over 3 minus pi times 0 cubed over 3. And well, that is nothing but pi over 3. The volume of that object is going to be pi over 3. How about this other one? Okay, again, first draw or sketch the graph and then the region that we are going to rotate. In this case, this is root x. It will be something like that. And x equal to 4 and x-axis. So the region is this guy here. Then we start rotating it. So rotate. And we are rotating about x-axis. So that means that we are going to get something like, okay, let me first sketch this part. Okay, and so it will be something. This one doesn't like it. Something like that. So the solid is something like ball. well, solid ball. Okay, and what is the volume? The volume is going to be integral from 0 to 4 pi f of x. Here is root x, so root x squared dx. This is integral of x dx, 0 to 4, and this is pi x squared over 2 going from 0 to 4, which will give us pi 16 over 2 minus pi 0 squared over 2, which all together would give us 8 pi. So when someone asks you to find volume of solid obtained by rotating about x-axis, you have to first write the sketch the graph of that region, find the limits, bounds of the interval, and then use this formula, pi fx squared dx integrated from a to b.